G'day, Mark Pesci here. I am the Honorary Associate in the Digital Cultures program at the College of Media and Communications. I'm going to be talking to you now about the history of spatial computing. That's virtual and augmented realities, but that's the term we're using these days. And we're going to divide this into two parts because the history actually stretches back almost 70 years. And so we're going to take the first part, which will take us up to about 2015, and then part two will take us from 2015 through to 2025. All right, so let's get started here. The roots of virtual reality, augmented reality, spatial computing as we know them emerge in the years following the Second World War. So it turns out that in a lot of ways, the machinery that the US was producing in the Cold War to defend itself against the Soviet Union was getting to be very sophisticated, and this was sort of very visible in the F-86 jet fighter. This is the first jet fighter that was really deployed for fight combat situations. It was used briefly in North Korea and then was used in many situations after that. It is a complex object, and a pilot would need to be across basically all of the controls because those are flight controls, fuel controls, altitude controls, path controls, bombing controls, awareness of the enemy controls, all of the armament controls. All of that is producing a state, and the pilot needs to be situationally aware across all of that state all of the time. And we've gotten to the point with the F-86A where the cognitive capacity of any pilot, no matter how talented, is basically being taxed to its limits by their ability to maintain situational awareness across all of the interfaces in this aircraft. And so we've gotten to a point where it's now possible to make machines that are more sophisticated than a human being can master because they're simply presenting more inputs that need to be integrated in real time. So what we see now is there's a very strong drive, particularly from the defense sector in the United States, which is funding a huge amount of research to actually start to solve some of these problems meaningfully. First individual who really came up with solutions and came up with a series of solutions, as we'll see, is Ivan Sutherland. So Ivan Sutherland did his work at MIT as an undergraduate and then graduate student, and also was in the Air Force. And while he was doing his PhD, he tackled this problem head on. Now, Ivan was in a very interesting period in computing because we were seeing the transition for what we'd call batch computing, where you'd feed a whole bunch of instructions into a computer and then run them and then go read what the computer did and maybe fix it if it didn't work, to what we would call interactive computing, where you and the computer are actually locked in a tight loop of interactions, and each of you are constantly guiding the other. And this is the beginning of interactive computing. Sutherland had access to an interactive computer, and not just an interactive computer with an interface called a light pen, which is a pen that you touch to the screen, and then it feeds back information into the computer in real time. And with that, he created the world's very first interactive computer program, something called Sketchpad, all the way back from 1963. And when I say the first, I mean the very first. So anytime you touch your smartphone and it interacts with you, anytime you open up Photoshop and draw something and it interacts with you, what you're doing is you are using the exact same interface elements and ideas that Ivan Sutherland founded over 60 years ago in Sketchpad. So all interactive computing that we have today, and no matter what form, basically descends from Ivan Sutherland's work in Sketchpad. And if he had only done that, he would be remembered as one of the titans of computing. But he was just getting started. So he leaves MIT with his PhD and he goes to work at what was called then DARPA, the Defense Advanced Research Projects Agency, in the Information Processing Technologies Division. And this was a very important part of the Pentagon because this is the part of the Pentagon that would eventually pay for the creation of the Internet. But at this point, with Sutherland in charge, they're actually looking at interface work. And while he's there, he writes a paper, very short paper, but very influential, called The Ultimate Display. You can see it right here on the screen. It is not big. You can go find it. Just Google The Ultimate Display. It'll come right up. You can read it. It's about 600 words. And it proposes that if we're really going to make computers useful, we have to provide as much display to the user as possible. And there's kind of two ways to do this. Either you can encase the user in a bubble of displays. And if you think about how gamers like to work these days with these big curving displays, that's kind of the beginnings of what Sutherland was talking about, but sort of at full scale, just putting someone in a bubble of displays. Or, he said, we can invent a kind of display that tracks where the user is, so that wherever the user looks, that's where the display is. And that is the genesis idea for where we get spatial computing, for where we get virtual reality and augmented reality. So Sutherland puts this paper out there to get people thinking, but he does more than that, because he leaves the Pentagon, goes and founds a lab at Harvard University, and spends 3 years building what he thinks of as the first version of the ultimate display. It's called the Sword of Damocles. Now, what you're seeing on the screen is how it looks to a person. These are cathode ray tubes, which are very big and very heavy, then shot through a whole series of mirrors down a series of tubes, and then reflecting into displays that are in the eyes. Now, the displays that are in the eyes are half silvered. So in other words, what you're getting is you're getting what's both in the world, and you're getting what the computer is generating where you're looking in that world. So it's pass-through. This is what we would think of as augmented reality. So in fact, augmented reality is not new. It goes back as far as virtual reality. They're invented at the same moment in the same device, this device by Ivan Sutherland. Now, at the time here, Sutherland had to invent two things that simply did not exist. He had to be able to find a way to be able to track the head as the head was moving around. We'll come to that in just a second. But the other thing he had to do is he had to be able to generate images in real time for these displays that would be updated in real time in 3D as the user's head moved. And so Sutherland also then invented real-time 3D computer graphics. I want you to think about that for a second. Every time you play any sort of computer game, anytime you see anything in 3D on the web or in a computer game or in a games console or on your smartphone, it is all work that was originally invented by Ivan Sutherland for this head-mounted display system back in 1968. So let's talk about the tracking now, because not only did he invent 3D computer graphics, he invented a way to be able to track the human head. And basically he did this by putting an armature connecting the head up to a whole series of controls and measurements up in the ceiling. And it hung down on the user. This is why it was called the Sword of Damocles, because it hung over the person that was using it. And as the person moved around, the mechanical tracking would then feed data into the computer that would keep the displays updated, so that wherever you looked, the displays would be updated to reflect the 3D view of the world that you were looking out on. So, this is 1968. This is called a head-mounted display. It is his ultimate display. It's part of the Fall Joint Computing Conference, which happens in December of 1968, probably the seminal event in the history of computing. And because of that, it becomes part of the canon of where computing will be going. It becomes a vision for the future of computing. But that said, not a lot happened with Sutherland's work. It took almost 20 years. And then there were another group of researchers who had a different problem that they needed to solve. And that group of researchers was at NASA. So NASA was flying the space shuttle back then. And space shuttle pilots and astronauts would train for their missions down on the ground in these great big pools. They'd put their spacesuit suits on, they'd go in the pool, and they'd rehearse their missions over and over again, because the point with them is to give them muscle memory so that when they get out in space, they know exactly what to do because their bodies remember. And that works great. But what happens if you have to assign a mission, say a repair mission, when the spacecraft is already in flight? You can't bring them back down to swim them in the pool. So you need a system that would allow them to rehearse the operation in flight. And this is when they said, oh, wait, Ivan Sutherland's kind of solved this problem. And they reinvented Sutherland's technology as the Virtual Environment Workstation, or VIEW. And this is what we think of as pretty much the first modern virtual reality system, because it's got the hallmarks of a virtual reality system. As you can see, it has a big head-mounted display popped over the user's face. We call that a face sucker these days because it is so big. It's got 2 stereo displays created and lenses that are putting computer-generated images into the eyes. It has 2 gloves on the hands called data gloves that are both measuring where the fingers are, but are also measuring where the hands are. So we now have not mechanical trackers, because there has been 20 years of progress. We now have magnetic trackers. Magnetic trackers send magnetic pings out into space, and then a tracker on the head and a tracker on the hands receives that ping, and from that ping knows where they are in space, and then feeds that into the computer program that's generating the virtual world. So you have the head and its orientation, and the hands and their position and orientation orientation in space being fed simultaneously into a system. So we look at this image. This image is profoundly influential. This was the first image where most people had ever even thought of or heard of the term virtual reality. And this image became a lightning rod for what the future was going to look like. Because people looked at this and said, oh my gosh, we're all going to have virtual reality systems. We're all going to be living inside of virtual worlds. Whole genres of science fiction was spun out of this, but also, interestingly, some video game products. And so, 3 years after this, Nintendo decides they're going to get on in virtual reality with something that they call the PowerGlove. And the PowerGlove was basically a scaled-down, cheaper version of the Data Glove that you put on your hand, and then you point it at the television. It would let you operate your Nintendo. And this is just a Super Nintendo. This is not one of the fancy new Nintendos. A Super Nintendo cartridge just by pointing at the screen. And there was a sensor on top of the television set that was measuring where the hand was and how the hand was turning so that it could be then fed into the real-time program on the Nintendo to be able to act as a controller for your Nintendo game. And that all sounds really amazing, except you can't hold your hand out from your body for very long, maybe 30 seconds, maybe a minute, and certainly a 6 or 7 or 8-year-old isn't really even going to have that kind of body strength. And so, although this device was designed to do something very specific and did that thing, it wasn't designed with any awareness of how people would actually be using it in practice. And so Nintendo sold a lot of these briefly for Christmas in 1989, and then they basically all got shelved, and then Nintendo canceled the product because people weren't buying anymore because kids couldn't actually use them. And this brings us to something that's really important to remember about virtual reality, is that it is possible to design systems that the body can't tolerate. If you think about the F-86, that was a system that the body couldn't process. Well, this is the same thing. We keep on making these mistakes because we keep on not testing and not giving these systems to use people to test on to find out their reactions before we actually go and try to actually hand them to people. So the PowerGlove was interesting, but it was a complete failure. But that doesn't mean that consumer electronics companies didn't keep on trying to make virtual reality systems. And Sega, which was Nintendo's big competitor back in the early 1990s, and in fact had beaten Nintendo at their own game with the Sega Genesis, decided that they were going to create a virtual reality headset that would just plug into the Sega Genesis. They called this the Virtual VR. Now, here I have to admit, I was one of the designers of the Virtual VR. Its ability to be able to track your head wherever it moves, I have a patent on that design. So I got to see this close up, and it was a consumer electronics project, and they said, okay, we're going to be able to do all of this on the not very strong microprocessor that's in a Genesis and do all the tracking and all of these things. And we built the system and we got it to work, but the system was slow. And it turns out that when virtual reality is slow to track people, there's a desynchronization between your brain and your body, and that tends to make people motion sick. And motion sickness is a big problem even today in most virtual reality systems. They're generally fine for 21-year-old men because 21-year-old men can handle almost anything. But if you get older people or people who are just a little bit not well, these systems still tend to, no matter how well they're engineered, how responsive they are, tend to make people a little bit sick. So the Sega Virtual VR was canceled before it was released. It had gotten enormous press coverage, enormous numbers of pre-orders, but Sega realized they could never release it because they were going to release a product that would have been a bigger hole in the ground than even the Nintendo PowerGlove. And then at the same time, you start to see the web come out, because the web comes out sort of 92, 93, 94, and there was a move to put virtual reality on the web with something called the Virtual Reality Modeling Language, or VRML, which put VR into a browser. So this got the idea of people being able to access 3D virtual worlds, not immersively, but on a screen. And for a period of time, VRML looked like it might be the future of computing. Problem is, it's also very hard for people to author their own virtual worlds. It was hard for people to connect and share their virtual worlds. There wasn't any high-speed networking back then. Virtual worlds are quite big. They take a lot of time to download. So it never really quite caught on the way that it could have. But there were two trends that were happening that was going to transform everything about virtual reality. The first comes from what we call Moore's Law. So Moore's Law says that basically every 18 to 24 months, computers get twice as fast for the same price. And that was very much in effect in the 1990s and the 2000s. And you can see this with just the character of Lara Croft from the video game Tomb Raider, because at the beginning, Lara Croft is very blocky and very roughly drawn, and by 2016, she looks like she's almost a cinema character. And why is this? It's because computers got 10,000 times faster over that period of time due to Moore's law. So things that were hard to do, that were slow to do, that kept things from interacting well, became easy and clear and also very richly detailed. And this was being driven not by the defense sector, but by the consumer sector. It was being driven by the rise in video gaming, because video gaming moves from the margins to the mainstream over the period from 1994 to 2016. Everyone video games. Therefore, there's an enormous market. There's an enormous budget for research. There's an enormous budget for games creation and for hardware creation that can use all of these technologies well in the service of the consumer. So you now have that new driver of technologies, but you also have another significant new driver of technologies, which is the smartphone. So the smartphone is introduced in 2007 with the iPhone. By around 2012, 2013, there's almost 2 billion of them in circulation. Certainly everyone in the OECD, which is around 2 billion people, probably has a smartphone. On its way to 5 billion people having a smartphone, which is roughly the number today. And in 2014, some engineers at Google realized that the generation of smartphones that were just coming to market were now fast enough and capable enough and had enough 3D horsepower that you could actually create a realistic virtual reality system on a smartphone. And you could do it so simply that all it would take was a piece of cardboard and 2 very cheap lenses. And in fact, apparently the original prototype was made out of a pizza box that they basically just bent up into shape and stuck some cheap plastic lenses they had lying around and slapped it on the screen and wrote some code for the smartphone that created a stereo pair, 2 different stereo images on the display of the smartphone. You pop your smartphone inside this case, put it up to your head, and look around, and you're in the virtual world. Why? Because a smartphone has sensors. It has accelerometers to be able to tell where you're looking and how the phone is being held. And those sensors were good enough, plus the computer was fast enough, plus the graphics were fast enough to create realistic virtual reality. All of a sudden, and I mean literally all of a sudden, when these folks walked off stage in June of 2014 after introducing this, the number of virtual reality systems in the world, which was probably only in the low thousands in 2014, by the time they walk off, is now in the low billions. Because all it takes is about 50 cents of hardware and a little bit of software to create a hand-contained virtual reality system. So all of a sudden, everything that had been hard and expensive is now easy and is now cheap. And of course, the consumer electronics device manufacturers are on this. And so by the next year, Samsung has integrated a very high quality version of the cardboard that they call the Gear VR. And it just, you pop your Samsung smartphone in, you turn it in, and you now have a high quality, high speed, high fidelity VR system. And they gave it to you free when you bought your Samsung smartphone. So it's really just something that they're using to be able to sell you more smartphones. So this is now we're starting to enter the modern age of virtual reality, because you get the incredible performance increases in computing, plus of course the realization that everyone was already carrying a platform that could be used for virtual reality. And this is important to remember, because as we enter part 2, we're going to see a new generation of virtual reality systems, all of which are basically nothing more than rearranged versions of smartphones. Okay, that's the end of part 1. And if you have any questions, please drop me a message at my email. I'll be happy to answer them. And please go on and watch part 2. I'm Mark Pesce. Thank you.